On April 27, 2011, the sky unleashed its fury, spawning over 200 tornadoes in a single day. April 27, 2011. By the end of the day, more than 200 tornadoes would touch down across the southeastern United States, but at sunrise, no one could see what was truly coming. The sky over Alabama is already unstable. Warm, humid air surges north from the Gulf of Mexico. High above, powerful winds scream across the jet stream. The atmosphere is layered, twisted, loaded. Meteorologists issue warnings early. This isn't a routine storm risk. It's labeled a high risk, the most dangerous category. Tornadoes form, radar fills, outbreak begins. By nightfall, entire communities will be erased. Over 300 people will lose their lives. And one question will echo long after the winds stop. How did the atmosphere produce this many tornadoes in one day? To understand that, we have to go back, before the first warning, before the first funnel, before the sky broke. Unimaginable. 2 days before the outbreak, the pattern is already forming. A massive low-pressure system begins organizing over the central United States. Cold air pushes south from the Rockies. At the same time, the Gulf of Mexico opens like a valve. Warm, moisture-rich air surges northward into Mississippi, Alabama, and Tennessee. Dew points climb into the upper 60s. For late April, that's fuel. Above the surface, winds begin to intensify. At 5,000 feet, they blow from the south. At 20,000 feet, they scream from the southwest. At 30,000 feet, the jet stream roars past at over 100 miles per hour. The atmosphere is no longer stacked. It's sheared. Wind shear, the change of wind speed and direction with height, is one of the primary ingredients for rotating storms. By April 26th, forecasters at the Storm Prediction Center are watching closely. Computer models begin showing discrete supercells, long-lived, violent, capable of producing strong tornadoes. They issue a rare outlook. High risk. That category is not used lightly. It signals the potential for widespread, significant tornadoes. By the evening of April 26th, the first wave begins. Several tornadoes touch down overnight. Power outages spread across Alabama. But the main system hasn't even arrived yet. Overnight, the atmosphere resets, moisture refills, winds strengthen. The stage is set. By sunrise on April 27th, the southeastern United States is sitting beneath one of the most volatile atmospheric setups ever recorded. Surface temperatures are expected to climb quickly. Sun breaks through morning clouds, adding instability to an already unstable air mass. Convective available potential energy, CAPE, rises to extreme levels. That means rising air will explode upward once storms initiate. Lift plus shear plus instability equals rotation. Forecasters know the equation. Aligned now. The first wave is already underway. Storms that formed overnight intensify as daylight breaks. Embedded supercells move across northern Alabama and Mississippi. Radar shows tight rotation. Velocity signatures deepen. The atmosphere did not calm overnight. It strengthened. Tornado warnings begin stacking on top of each other. Some communities receive multiple warnings within hours. Sirens cycle repeatedly. Power flickers, then fails. Embedded supercells move across northern Alabama and Mississippi. Radar shows tight rotation. Velocity signatures deepen. By mid-morning, the storm mode shifts. Instead of a single broken line, discrete supercells begin firing ahead of the main front. Isolated, uninterrupted, free to rotate, each one capable of producing a long-track tornado. Meteorologists notice something alarming. The storms are not interfering with each other. They are spaced perfectly, like gears in a machine. Rotation after rotation appears on radar. Hook echoes bloom. Debris balls begin showing up, confirmation that tornadoes are on the ground. In some towns, emergency managers struggle to keep up. Warnings are issued faster than they can relay them. Schools shelter in hallways. Hospitals move patients away from windows. And still, it's not yet noon. The morning round produces dozens of tornadoes. Not one catastrophic event, but many strong, damaging storms. Radar saturated, warnings stack, environment intensifies. Storm reports begin flooding in, mobile homes damaged, yet radar remains saturated with rotation. New warnings replace expired ones. Forecasters use phrases rarely spoken on air. Particularly dangerous situation, because by 11 a.m. the environment has intensified, strengthening. Still, the tornadoes are no longer isolated emergencies. They are systemic. As multiple supercells carve across Alabama and Mississippi, the electrical grid begins to fail. Transmission towers buckle under straight-line winds. Substations are struck by debris, high-voltage lines snap and arc in open air. Entire counties lose power within minutes. By noon, hundreds of thousands are in the dark. And it's not just inconvenient, it's dangerous. Weather radios go silent, cell towers begin failing. Television broadcasts cut in and out. Forecasters are still issuing warnings, but many people can no longer receive them. This is the second layer of the outbreak. Not just tornadoes. Infrastructure collapse. Some areas are hit twice in the same morning. Emergency responders struggle to navigate blocked roads, downed trees, overturned vehicles, live wires across highways. Hospitals switch to backup generators. Dispatch centers reroute calls. Communication becomes fragmented. The storms continue moving east, and the power continues failing. By early afternoon, over 1 million customers across the southeast are without electricity. In Alabama alone, large portions of the grid are offline. Meteorologists later describe it as one of the most widespread power failures ever caused by a tornado outbreak. And it happens before the main event, because the atmosphere is still destabilizing, still heating, still shearing. The strongest upper-level dynamics have not yet arrived. The grid is weakened, the population is partially blind, and the most violent storms of the day are just beginning to form. Sirens fail, people shelter, outbreak overwhelming. Utility crews cannot respond fast enough. In some cities, sirens fail after repeated activations. Battery backups drain. Warning, impact, silence. Then another warning, people shelter without updates. Meanwhile, radar operators watch supercells mature. Rotation tightens. The outbreak is operationally overwhelming, and it is not slowing down. Afternoon approaches. Fast, now. The atmosphere detonates. As the main upper-level trough swings east, lift intensifies dramatically. Supercells erupt across Mississippi and Alabama almost simultaneously. Not scattered, not isolated, explosive. Within minutes, radar lights up with rotating storms. Velocity signatures tighten. Hook echoes sharpen. The environment is now primed for long-track, violent tornadoes. Low-level winds strengthen further, increasing storm relative helicity, the measure of spin available to a storm. That spin is immediately ingested. By early afternoon, multiple tornadoes are on the ground at the same time. Some track for miles, others begin carving paths that will exceed 50 miles. Debris balls appear on radar, large, persistent, unmistakable. These are not brief touchdowns, they are sustained vortices. Forecasters begin using urgent language. Large and extremely dangerous tornado. Take cover now. Communities from Mississippi into central Alabama are placed under continuous warnings. The storms are no longer cycling weekly, they are sustaining violent rotation for extended periods. The atmosphere has removed its limits. By 2 p.m., the outbreak is historic. Dozens of tornadoes are confirmed. Emergency services are overwhelmed. Power outages climb into the millions. EF4s and EF5s, long track, erasing neighborhoods. Because embedded within this expanding cluster of supercells are storms that will soon become EF4 and EF5 tornadoes. Long track, wedge-shaped, capable of erasing entire neighborhoods. Between 1 o'clock and 3 p.m., new supercells continue firing ahead of the main line. Each one taps into the same volatile air mass. Storm bases lower, wall clouds tighten. Spotters report rapid rotation within minutes of formation. This is not a single dominant storm. It is a field of rotating engines. Meteorologists track storm after storm, producing tornado warnings. Some warnings overlap geographically, some overlap in time. In certain counties, 2 tornadoes are on the ground simultaneously. Wind fields expand. Damage paths widen. Some tornadoes grow into wedges more than half a mile wide. No pause, no recovery. Outbreak accelerating. One storm separates itself from the rest. It begins as just another supercell west of Tuscaloosa, Alabama. But radar quickly shows something different. Rotation is deep, persistent, tight. A large tornado touches down near the town of Sawyerville. Within minutes, it intensifies. By the time it approaches Tuscaloosa, it has grown into a massive wedge tornado, nearly a mile wide. Debris is lofted thousands of feet into the air. Radar confirms a debris ball. Homes, trees, vehicles shredded and lifted. The tornado enters the western edge of Tuscaloosa at peak strength. Entire neighborhoods are leveled. Concrete buildings are gutted, apartment complexes collapse. Traffic clogs major roads as people attempt to flee. Some are caught in vehicles. Others shelter in place as windows implode. The circulation remains violent as it crosses the Black Warrior River and continues toward Birmingham. This is not a brief touchdown. It is a long-track EF4 tornado carving a path more than 80 miles long. Emergency broadcasts plead with residents. You cannot survive this above ground. Power flashes explode across the skyline. Cell service collapses. Hospitals prepare for mass casualties. As the tornado enters the Birmingham metropolitan area, it maintains destructive intensity. Subdivisions are flattened, schools are damaged, entire blocks are reduced to foundations. By the time the circulation finally weakens, dozens are dead, hundreds are injured. The Tuscaloosa-Birmingham tornado becomes one of the most infamous storms of the outbreak. First responders move into debris fields while sirens continue elsewhere. Residents emerge into landscapes they no longer recognize. Street signs are gone, landmarks erased, entire subdivisions reduced to slabs and splintered wood. Meteorologists later analyzed the velocity data. Wind speeds likely exceeded 190 miles per hour at times. The circulation remained organized for over an hour. It was not random chaos. It was sustained atmospheric violence. Sustained violence, live broadcast, defining image. And it happened in broad daylight, broadcast live on television as viewers watched the wedge advance toward population centers. For many across Alabama, this storm becomes the defining image of April 27th. But it is only one of several violent tornadoes unfolding that afternoon. Even as Tuscaloosa and Birmingham absorb catastrophic damage, another supercell to the north is strengthening, and it will soon produce an EF5. Relentless, unyielding, historic, unstoppable, devastating, severe, powerful, massive, deadly, historic. Multiple supercells across northern Alabama and Mississippi begin producing tornadoes rated EF5, the highest classification on the enhanced Fujita scale. These are not just strong tornadoes, they are catastrophic. Near Hackleburg and Phil Campbell, Alabama, one EF5 carves a path more than 130 miles long. Entire neighborhoods are swept clean. Well-built homes are reduced to bare slabs. Large hardwood trees are stripped of bark. The tornado maintains EF4 to EF5 intensity for over an hour. Further north, near Smithville, Mississippi, another EF5 touches down. It intensifies rapidly. Concrete foundations are scoured. Vehicles are thrown hundreds of yards. Infrastructure is obliterated. These storms are not brief spikes in intensity. They are sustained, violent circulations fueled by perfect wind alignment from the surface to the jet stream. Low-level winds exceed 50 miles per hour. Mid-level winds surpass 70. Upper-level winds scream past 100. The vertical wind profile is nearly ideal. Storms tilt, rotate, sustain. Multiple EF5s emergency, unreachable, communities vanish. Damage surveys later reveal wind speeds exceeding 200 miles per hour in some locations. Entire communities vanish from the landscape. In total, April 27, 2011 will produce 4 EF5 tornadoes. A rare number for any year, unprecedented for a single day in the modern era. The outbreak now spans from Mississippi through Alabama, Georgia, and into Tennessee. Over 300 people have been killed, thousands are injured. The sky has produced more than 100 tornadoes in just 24 hours, and it is still not done. Nightfall approaches, atmosphere spins, damage historic. Nightfall approaches, and the atmosphere continues spinning. As darkness falls, storms continue crossing state lines. Some tornadoes remain rain-wrapped and nearly invisible. Communities already struck earlier brace for new warnings. Meteorologists work in clipped, urgent tones. The atmospheric engine refuses to shut down. Even after sunset, low-level winds remain strong. Until the cold front sweeps east that night, the outbreak will not end. By then, the damage is historic. Damage assessments the next day will reveal entire neighborhoods removed from maps. Survey teams will document homes swept from foundations, anchor bolts bent. These are indicators of strongest rating. The enhanced Fujita scale tops out at EF5 for a reason. Above 200 mile-per-hour winds, structures disintegrate. On April 27th, that threshold was crossed, and the atmosphere did it repeatedly. In many places, the sky is finally dark, but the radar is not. Storms continue pushing east into Georgia and the Carolinas. Some weaken. Even after producing violent tornadoes for nearly 12 hours, the atmosphere still contains enough instability and shear to sustain additional rotation. Warnings remain active well into the night. Communities already devastated earlier in the day brace for yet another impact. Rain-wrapped circulations move through rural areas. Harder to see, but still dangerous. The cold front finally begins overtaking the warm sector. Cooler air filters in behind the line of storms. Rotation weakens, storms merge into a squall line. The discrete engines that dominated the afternoon begin losing their structure. By midnight, the worst is over, but the scale of what happened is still unfolding. Because April 27th did not produce one historic tornado, it produced an outbreak so vast, so intense, that it reshaped how meteorologists and emergency managers understand large-scale severe weather events. And when the sun rises the next morning, the damage will stretch across multiple states. Visible, unavoidable. Over 200 tornadoes confirmed across the southeastern United States in roughly 24 hours. Of those, more than a dozen are rated EF4 or EF5. 4 reach EF5 intensity. It becomes the largest tornado outbreak ever recorded in the month of April, one of the largest in modern history. More than 300 people lose their lives. Thousands are injured. Entire towns in Alabama and Mississippi are fundamentally altered. At peak, more than 4 million customers lose power. Some communities remain without electricity for weeks. Damage estimates climb into the billions of dollars. But numbers alone cannot capture what happened. Because behind every statistic is a home, a family, a street that no longer exists. April 2007-2011 becomes known simply as the super outbreak, a benchmark event in meteorology, a case study in atmospheric alignment, and a reminder of how quickly conditions can escalate when moisture, instability, shear, and lift combine perfectly. In less than a day, the sky produced destruction on a scale rarely seen outside of hurricanes or major earthquakes, and it did it with rotating columns of air. A single weather system, one day, nation-changing, historic, unprecedented, defining. Forecast models were refined, warning communication improved, infrastructure planning was reevaluated across tornado-prone states. The outbreak became a teaching tool in universities. Radar loops from that day are still studied. So are the forecast discussions issued hours before the first tornado formed. Because, despite the devastation, the event was forecast remarkably well. The Storm Prediction Center had issued a high-risk outlook. Forecasters warned of long-track, violent tornadoes. And still, the scale overwhelmed entire regions. The lesson was not that the atmosphere failed to warn. It was that even perfect forecasts cannot eliminate risk when conditions align this precisely. April 27th proved something unsettling. The United States is capable of experiencing multi-state, multi-hour, violent tornado production on a scale rivaling the worst events in recorded history. And it can happen in a single day. The sky does not need weeks to prepare. It needs alignment, moisture, instability, shear, lift. When those elements synchronize, the atmosphere becomes a machine. On April 27, 2011, that machine ran without restraint. And the scars remain, still visible. So yeah, if you want to understand how weather can reshape history, subscribe to the channel and like this video.